Okay, so this is the last one that we'll do for today. So this one is about a plane that's flying. I don't know why it's like a stealth bomber. That's hilarious to me. It's not just like a regular plane, it's like a warplane. All right. A plane is at an altitude of 4,000 feet. That's not changing. It's flying at a constant altitude. So the 4,000 is constant. It's flying west. Let me go ahead and make it fly. All right, so there it goes. 700 feet per second. The searchlight under its path is tracking it. So here, let me wait till it comes back. There you go. All right, so this is the angle that we're looking at there. How fast is the light pivoting? So we are being asked about the rate for this angle now. This is the rate for that angle is what we're trying to find. When the plane is 1,000 feet east. So when the plane is like right there-ish, okay? I guess 1,000 feet would be a little closer. But anyway, when the plane's like right here is when we're gonna pause. So that is what is going on in that problem. All right, so let's go ahead. Well, I think they use spotlights on a lot of planes, I think. I don't know anything about aviation. I know how to do this problem though. All right, so let's go ahead and draw our right triangle. And again, the altitude is constant. So this is gonna be 4,000 feet. That is not changing. So this distance is 4,000. The angle is changing though, so I need to label that something. I'm gonna use theta. We usually use theta for an angle. And then this distance was changing. I think they used x for that, so we'll call that x. And the plane is flying this way. So they said the plane is flying at 700 feet per second. That is a rate. So how will I label that 700 feet per second? What am I gonna call that? If that's the rate that the plane is flying, what will I call that in my list here? The rate for the plane. Good, nice, dx dt. That's the rate at which this x distance is changing. So that's the rate at which the plane is flying. You really only had two choices because there's only x and theta, so that's really it. It's 700 feet per second, but it's gonna be negative because the plane is flying towards the searchlight, and so that distance is decreasing. So negative 700 feet per second. Our question mark value, it's asking about the rate of change for the angle. So good, d theta dt, and should that be positive or negative? And good, yes, that will be negative. As the plane is flying, that angle is getting smaller and smaller until it's nothing. So that should be negative. And then we have to pause at a certain moment, and it said when the plane is 1,000 feet east. So when x is 1,000. So now we need a relationship between the variables. We cannot use Pythagorean theorem for a couple of reasons. First of all, we don't have the hypotenuse. And secondly, we have to include this angle somehow. So we're gonna need trig. It's gonna be sine, cosine, or tangent. So here's the angle. X is opposite and 4,000 is adjacent. We don't have the hypotenuse. So which trig function, think of your SOHCAHTOA, do we want sine, cosine, or tangent, guys? We have the opposite and the adjacent. So is that gonna be sine, cosine, or tangent? You have to channel your geometry material. Yes, good, tangent. Nice job, guys. All right, so tangent of theta equals x over 4,000. Now this is totally a personal preference. You don't have to do this. I don't like the fraction in there, so when I get something like this, I usually multiply that number over. So I'm gonna write this as 4,000 tangent of theta, just so I don't have a 1/4000th in there. That is my personal preference. If you disagree, like we're just different, okay? I like to multiply that over though, so I don't have a fraction. All right, now we're gonna do the derivative. So derivative of tangent is secant squared theta, and then d theta dt. And then derivative of x is dx dt. And then we're gonna start plugging stuff in. All right, so this would be 4,000 secant of theta squared. I'm gonna have to come back to that. It's gonna be whatever secant of theta is squared, but I don't have secant of theta. I don't even have theta, so we're gonna have to come back to that. All right, d theta dt is what we're trying to find, so I'm gonna leave that in there. And dx dt is negative 700. All Right, so we're gonna have to come back to the original relationship here, the original triangle. I'm actually not gonna use this. I'm just gonna redraw the triangle and put in what we know. We know that x is 100. Oh, someone just asked, you can't see it because it was to me privately, but in the chat, the 4,000 was just a coefficient multiplied to the tangent, so it stays multiplied to the derivative. I get what your question is though. Hold on one second. Let me write it differently. If instead of 4,000 times tangent, if it was 4,000 plus tangent, like they were two separate terms, then this would go to 0 because it's a constant. But in this case, it was a coefficient, so it's just being multiplied on. Oh, and I'm sorry, was this 1,000 instead of 100? Someone else sent that to me privately. I apologize. 1,000 feet. I'm sure you're right. I'm trying to like look backward and forward. I wrote the problem down in my notes here because I can't have the screen with the information on it and my notes up at the same time. So I'm kind of juggling a lot of things. I think you're right. That was 1,000. Yes, you are correct. Thank you. Okay, cool. Sorry, trying to answer two questions at once there. All right, so what I'm going to do is redraw this triangle and put that 1,000 in here. So here's theta. This is 4,000. This is 1,000. I'm going to do Pythagorean theorem to get the other side, and then we can use our SOHCAHTOA from back in geometry to do secant, all right? So I realize these are large numbers, but that's okay. I'm going to pick up a calculator here in a second. This would be 4,000 squared plus 1,000 squared equals the hypotenuse squared. I'm just going to call it C because you usually see that as, you know, A, B, and C. And I'm just going to type that in just for the sake of simplicity so I don't make a mistake with all the zeros here. So 4,000 squared plus 1,000 squared is 17 million. So this is going to be the square root of 17 million. I realize that's annoying, like it's a lot of zeros. Pretend it's your paycheck and then you'll feel happier about it. I know it's like I have to write all those numbers out. It's fine. It's going to be okay. Right? Just people get worried with when the numbers get large. It was just the numbers were in the thousands. It's a big number, right? So to review our SOHCAHTOA, cosine of an angle is adjacent over hypotenuse. So secant, because that's what we're trying to find, would be hypotenuse over adjacent. It's the reciprocal function of cosine. So if we do hypotenuse over adjacent, that's going to be this crazy square root, this square root of 17 million over the adjacent, which is 4,000. All right, and if you're like, oh, those numbers are weird, Miss Cole, I'm sorry, but I'm sort of not. I mean, it's just numbers, it's just math, you know. So you can do it. Pep talk, it's good. You're gonna be fine. All right, and then we're going to square that. So the square root is gonna cancel. That would just be 17 million. And then you'd have 4,000 squared, but then there's another 4,000. So one of the 4,000s is gonna cancel. And you just have one left. Again, this was 4,000 squared in the denominator there, so one of the 4,000s canceled, so we just have one left. And the square root and the squared canceled, so just 17 million. d theta dt equals negative 700. And then to get this by itself, it's going to be negative 700 times the reciprocal. To cancel this out, you would multiply by the reciprocal. And I really don't care what that comes out to. If you want to type that in a calculator, you can. It's going to be some decimal. That's fine. I'm not worried about it. I'm going to just leave it like that. You do not have to simplify anything down. And notice we never even found theta. We didn't even need that angle. We just needed to be able to do hypotenuse over adjacent. So we never actually even found the angle. Units for this one. This is actually really tricky because these units are actually not given in the problem. All right. Whenever we're talking about an angle, it is either radians or degrees. And we only do radians in AP Calculus. We will not touch degrees. It will never be degrees. So for an angle, it is radians. This is going to be radians per, and then the time unit will stay the same, whatever time they gave, and it was seconds. So radians per second for this one. And that is tricky because those were not told to you in the problem. Just remember every angle is going to be radiant.